Anyone? Did Keith talk about catch curves at all? Maybe not. No? Okay, so a catch curve is basically just a relationship between you're plotting the natural log of the number of fish in a sample, so your catch. So this could be electrofishing catch data, this could be a trap net data, gill nets, what have you. So you have your log transformed catch values, your number of fish caught as a function of age, and age is on the x-axis. And so we've already kind of seen that basically. If we assume non-back calculated ages, we've already seen this kind of relationship. So when we plotted our data, we saw how many of the bass were at each of those age categories. And so in this description, it's talking about how the slope of the descending right limb of the plot is equal to the negative z value. And so those age groups, you can then determine the slope. And we're assuming that those are fully vulnerable to sampling gear. So the assumption is that age 1 fish are just as vulnerable to a trap net as age 4 or age 5 fish, which we know just like we can assume that that's not right, just because differences in body size affect the sampling efficiency for each of those gear types, right? But for this, we're assuming that age 1 fish is just as vulnerable as an age 5 fish. And so we're going to use Excel to determine the slope of the regression line for our data set. And so we see this little table right here where we've got age 1 with 115, age 2 with 75 fish, and so on. And so I want you guys to go ahead and use Excel to plot those into a simple catch curve, but make sure that you're log transforming these numbers. So first do a log transformation on 115, 75, 54, and so on. Don't transform your ages, just your catch data. And then once you have them transformed, you can go ahead and plot them. So let's start with these. These are flathead catfish from the Kansas River. So let's start with those. And then if that goes well, then you guys can go ahead and make a catch curve for the bass data. Sound good? Trevor, did you ever hear back from Hunter? He's not in the waiting room.
Yeah, so his phone or laptop keeps crashing.
Oh no.
Is what's happening now.
Okay, gotcha. That's a bummer. I'm recording this though, so I can post these afterwards for everybody. All right. So just as a quick check, you guys create something looking like this? Does that look similar? So we've got, yes? Okay. Aaron's giving me a thumbs up. Good. So remember, we're log transforming these values up here. So this column C is what's actually being plotted. So I log transformed my catch data and then plotted them against my ages. And that's how I made this catch curve. Does anyone want to show me their catch curves? Or I'd love to see if somebody could volunteer to show me one for the tallgrass bass, so everybody in the class can kind of see what it's supposed to look like for their reports. That'd be great. I'll give you guys a couple minutes to do that next one. Okay, how's everybody doing? Mind if I go ahead and share what mine looks like? And mind you, I might have missed one here. So basically, how I approached this is I went back to our table with all of the the consensus ages and then the mean calculated ages for all the readers, right? And I rounded up or down based on whether or not, like I rounded to whole numbers. So if it was 1.5 or over, I rounded it up to 2, right? And so on. And so then from those numbers, there were 4 fish at age 1. There was 1 fish that was age 2. There were 9 fish that were closest to age 3, and so on. And so let's see if I share my screen. And I might have miscounted those just a little bit, but you get the general idea. Let's see if I can't share my screen here. So then that created a catch curve that looks something like this. So definitely not as robust of a sample size for estimates. And we have some with 0 fish, right? But this would be our messy catch curve. And keep in mind, I log transformed those values. Could also do a catch curve without log transforming it. But that definitely like wouldn't be as clean and wouldn't meet the assumptions. You could present both if you wanted to. You could do side by side panels of log transformed and not log transformed, like raw data plotted right next to one another, and I'd be perfectly cool with that. Anybody get anything remotely close to that? Anybody want to show me a plot? Love to see your catch curves. Please show me your catch curves. Anybody have one to share that looks kind of like this? I'm sure that I did my totals wrong. I've got to be at least 1 fish off. I miss seeing you guys' smiling faces. This is so like anonymous and scary. It's very intimidating. Okay, seeing none, we will go ahead and move on because we don't have a ton of time today. But basically from those catch curves, then you can calculate the slope of the regression equation. And from that, you can also calculate the total instantaneous mortality, the total instantaneous survival rate, and the total annual mortality. So I'm going to go ahead and let you guys calculate these 4 values underneath this first table. And then when you have them, just chime in and share what you got. Okay? If I'd known everybody was going to stay muted today, I would have had like a ballin' Spotify playlist in the background queued up, ready to go. So I have some like dance house music for us. I feel like we need a soundtrack if we're not going to talk. Does anybody have the regression equation yet?
Is that for the first set of data, the catfish?
Yeah, we can do both of them.
So I think my slope was negative 0.2393.
Yep. Okay.
So then Z is just the positive version of that.
Yes. So next from Z, it's asking us to calculate S and A. And so remember, we can go back up to the page before and we can calculate that. If we assume that survival is 1 minus A, we can calculate S by doing e to the negative Z, since we've already calculated Z. Does that make sense, everyone? Thumbs up if that's kind of clear. On a scale of 1 to 5, with 5 being crystal clear and 1 being murky. Can you guys drop in the chat where we're at right now so I can kind of gauge? Okay. Okay. Good deal. All right, why don't we do an example then? So, all right, so Aaron, you got, what was your value again? It was like negative 0.2 something, right?
Yeah, 0.2393
Okay.
negative 0.2393 is negative Z.
Yep. 2.393. And then, so if you use that value and you plug it in into the equation Z equals ln S, or actually if we use Z equals F plus M, so we have our Z value. What else can we calculate from here?
You can just do, well, I guess e to the negative 0.2393 to get your instantaneous survival rate.
Yep. So what would that be then?
0.7872.
Yep.
For lack of going out to 500 digits.
Yeah, no need to do that. If you guys, for your reports, like keep 2 sig figs is cool with me. All right. And then, okay, so you've calculated S now. So how do we get to A? So if we know S, we know that the relationship for survival is 1 minus A, right? So we can solve for A and just add 1 to it. And so our annual mortality rate, if I did the math right there, would be 1.7872, rounding. All right. How are we doing now in terms of like our scale of 1 to 5? Get better? Okay, Audra's got a thumbs up. That's good. Excellent. Okay. All right, moving on, since we only have like 10 minutes left in here. I'm not going to spend a ton of time going through these because I'm not going to like quiz you or have you include these in your estimates or in your reports. But the next one that I want to talk about is 2 different versions of calculating survival rate estimation. And so if we go back to this page here. So scroll down and we've got the Heineke's method. And so this one is just assuming that survival is equal to the sum of n minus n naught divided by the sum of n. And so n is just your total number of fish across all age groups. And then n naught would be the number of fish in the first fully recruited age group. So that's all of your age ones. And so we can go ahead and calculate using the same flathead catfish data as before. We can calculate, and these values are going to be slightly different because we're not using a regression equation for these. So that's one method. And then I'm just going to go ahead and present this last method too. And then I'll give you guys some time because we only have 10 minutes left to calculate both of them. So this next one is the Chapman-Robson method. And so this is another common one. And so you see that the ages are coded. So we have 0 through 6 in a code. And then you use this formula. So S is equal to T divided by the sum of N, so your total number of fish, plus T minus 1. And then you've got this really long equation for T is equal to 1 times your N1 values plus 1 times your 2x values. So it's 2 times the N2 and so on. And then your sum of N would just be your sum of your N naughts, your N1s, N2s, and so on. So this one is like coding fish into different age groups. And so the general difference between the two, right, is that it's taking into consideration that age, like the differences between the age classes. And so it's like, it's kind of accounting for if you have variations in between age classes in recruitment and survival, right? So that's kind of the difference between the two. So we'll go ahead and I'm just going to give you the remaining time to calculate these values. And then your lab grade, your final lab grade for today will just be entering in these values in the blanks, answering the final question, and you can send that as a Word document to me for full points. Anybody got any values for the Heinke's method yet? Oh, and I should note that for these you don't log transform them. Yeah, just wanted to point that out. So we're doing these on the raw values. So those N values, we're summing the catch values from that second column.
Is S for the Heinke's method 0.63?
Let me get here. I got a new scientific calculator, guys, finally, at the end of the semester. I'm trying to get it to output for me.
That's what I got too.
What did you say you got?
0.63.
Yep. Okay. So from that, you can use the 0.63 to calculate the other two values, right? For anyone that's struggling with that right now, how they got those values, remember, is so they added up the 115, 75, 54, 40, and got a value that was right around like 351, I think 352. And then you subtract your N naught, which would be 115 from that. You get a value around 236, and then you divide that again by your total, which is the 350 value, and that's how you got the 0.63. Does that make sense? Good. So what's the first and like easiest value that we can take once we have our z value? What can we do from there? Sorry, we have s. So now we can calculate z, right? Because s is just 1 minus a. So we can find a, then we can also find z pretty easily. So you guys have values for either of those yet?
I got 0.462 for Z.
462. Let me check that.
What I got?
Six as well.
Yep. 46.
AB 1.63.
Yep. 1.63. You see how Billy got that, guys? So basically, if we know that survival, your S is equal to 1 minus A, you can just add that over to what your S value is, and that's how we got 1.63. Clear as mud?
Yep.
Cool. So we're running out of time, so I won't go through the calculations of Chapman-Robinson, but just go ahead and take a stab at them. And so you guys kind of see it's like taking into account, you do like the sum of each of those number values in there, and then it shows you how to calculate T. And so you've got 7 total ages, so you're going to have to go through and account for each of those ages. And then the sum of n value is going to be the sum of kind of like we just did where we calculated that big value of like 350 something. That would be the same thing as this sum of n here, same principle. So go ahead and fill out those values and answer the discussion question about the assumption of constant survival and recruitment. Think of some factors that might influence that, both human, like anthropogenic and natural factors from year to year, and write that up, and you can email that to me and get your points for today. Okay, our time is about to end. So does anybody have any final questions before we leave?
You said you're going to post these, right?
What's that?
You said you're going to post these recordings?
Yes, the recordings will get posted. It takes me like 30 minutes to upload each one to YouTube because it's really slow to render. But yeah, they should be by tonight. I can send out an email with the link to the YouTube channel.